Hello everyone, welcome to another episode from Chedexcel. Today I am going to talk to you about periodic table and the periodic patterns, periodicity. So this is like three parts. First we are going to discuss about the periodic table. Now why do we need a periodic table is scientists thought that we should have to have a proper classification of elements when the science gets developed. So earlier, about 2000 years ago, the scientists they used to have their own symbols to represent substances. Like they have their own symbol for fire, they have own symbol for earth, then water, silver, gold. Likewise, they have their own symbols. We call them as alchemists. So they have their own symbols. Now when the science developed, they found that having different symbols for the different substances is not going to help to develop the science. So they thought that we should have a proper classification of elements. So there were many scientists who came across with the proper idea or the classification. There were some scientists called Lodemeyer, and there are scientists called Newlands, and there are something like De Bruyne, like that. They have different scientists who came across with different ideas of how to clarify or how to classify elements. Now the modern periodic table is actually the one who developed or given by Dmitry Mendeleev, a Russian scientist. So he came across an idea that elements can be classified according to the increase in order of their atomic number. Now just before the Mendeleev came across about his idea, there was a scientist called Lodemeyer. He gave an idea about the volume of the atoms. So using the atoms and actually the mass of the atom as well, so using the previous ideas as well, Mendeleev came across an idea that we can classify elements according to their increase in order of the atomic number. The main difference with the Mendeleev periodic table with the periodic table that we have or that we used to have back then is Mendeleev thought that we haven't found all the elements back then. At the beginning, many people or many scientists laughed at him, saying that no, the science is developed, we don't have anything else to find, these are all our elements, because nobody expected that elements can have the atomic numbers gradually increasing one by one. They said earlier they thought that it can be a random thing. We can have element with atomic number 1, and then we have another element like 2, 3, and we might not have 4, we might have 5, we might not have 6, we might have 8, like that. But Mendeleev said no, all the elements increase their atomic number one by one. So if we don't have an element with atomic number, let's say 25, he said we haven't found that yet. We have 24, we have 26, we haven't found 25 yet. So it is yet to find. So he said we have to keep spaces for the unfound elements. So earlier the scientists will laugh at him, but later scientists could find 4 new elements. Those are mainly yttrium, erbium, terbium, ytterbium. So those are the 4 elements they found, and with the finding of those elements, scientists thought that Mendeleev's idea is correct, right? So that history normally no need to remember, but that's something to give us summarize about how the evolution of the periodic table. Now the modern periodic table, we have groups and we have periods. The vertical columns in the periodic table, we call these columns as groups, right? The vertical columns are called as groups, and then you can say we have horizontal lines, right? These horizontal lines we call them as periods. So vertical columns are groups, horizontal lines are periods, and we have normally 7 periods, like so 1, 2, 3, 4, like that. We have 7 periods, and groups wise, the modern periodic table we have 18 groups, right? We have 18 groups, but still most of the time we use the old notation where we have 8 groups. right. Now what is the difference between these 8 groups and 18 groups thingy? It's like this. Now the modern periodic table, what we normally get in the paper as well, you can see the periodic table they classify then as 1, 2, and then there is a part in the middle, it goes like 3, 4, 5, 6 like that. Okay, that's how it goes, and then start somewhere over here with 13, but we normally call them as 1, 2, and this one as 3. The one with 14 we have 4 like that, because sometimes or most of the cases when you talk about the compounds, the bonding, we don't use the new notation, we just use the old notation. So according to the old notation, group 13 is we call as group 3, group 14 we call them as group 4. Likewise, new notation we have 1, 2, 3, 4, 5, 6, likewise up to 18, right. So that one they don't ask normally. We will see how we have classified elements according to these groups and periods. Now the rough sketch, if we just take the periodic table, right, rough sketch of the periodic table, it's like this. We have small block like this, we have a middle block like this, then we have another block like that, and at the bottom we have another part like this, right. So we call this one as S block, we call this one as P block, we call this as D block, and this part as F block. So we will see what is this S, P, D and F blocks. Now if you can remember, when you talk about the electronic configuration, I told you that there are 4 types of subshells as S, P, D and F. So according to those S, P, D, F subshells, we have classified elements to S block, P block, D block and F block. So we will see what are those S, P, D and F, right. The S block elements are the elements present in first 2 groups, right. Group 1 and group 2 elements are called as S block, group 1 and group 2. So S block we have elements lithium, sodium, potassium, rubidium, cesium and francium. Group 2, this is group 1. Group 2 we have beryllium, magnesium, calcium, strontium, barium, radium, right. Those are the elements present in S block. Why do we call them as S block? We call them as S block because the outermost electron, or when the electrons are being filled, the final electron or the last electron is being filled into the subshell. So that's why we call them as S block element, right. So group 1 and group 2, all the elements are S block. All S block elements are metals. Their reactivity increases down the group. The metallic properties vary with the other metals. We will talk about them in chapter 3 under bonding and structure. So that is S block. We have elements from group 1 and group 2 and they are metals, right. So that's the main thing you have to remember about S block, right. Then when you go to the P block, P block is from group 3 to group 8 in the old notation, right. That part we call them as P block elements. So in the P block we have group 3, we have boron, aluminium, gallium, indium, thallium. Then group 4 we have carbon, silicon, germanium, tin, lead. Group 5 we have nitrogen, phosphorus, arsenic, antimony, bismuth. And group 6 we have oxygen, sulfur, selenium, tellurium, polonium. Group 7 we have fluorine, chlorine, bromine, iodine, astatine. Group 8 or group 0 we say, start from here because we have one on the top, helium, neon, argon, krypton, xenon, radon. So those are the elements that we have in P blocks, right. It's not a must to remember these elements. If you can, it's much better, but it's not a must. So group 3 or group 13, group 4 or group 14, 5 or 15, something like that. Now in P block we have both metals and non-metals. So generally if I draw a staircase like this, starting from boron, right? If I draw something like that, this side we call them as non-metals, and this side they are metals, right? So P block we have both metals and non-metals. Why do we call them as P block? We call them as P block because the outermost electron or the final electron is being filled into the p subshell or p orbital, right? Then that's for P block, right? Then we have D block, right? So let's say what is the D block is. The D block is the middle part between, we have S block over here, we have P block over here, the middle part is D. So there we learn in A2 the first row of the element, right? So we call them as 3D block or 3D block because their electrons are being filled to the D subshell, third main energy level D subshell. So we have there scandium, titanium, vanadium, chromium, manganese, ferrum, cobalt, nickel, copper, zinc. Those are the elements present in D block in the first row, and we have two more rows. We are not going to talk about them in A level, right? So D block elements are all metals and their reactivity is less than group 1 and 2 metals, but their hardness is much higher or the much larger, stronger than group 1 and 2 metals. Most of the D block elements are called as transition elements. We will talk about why they are called as transition elements in unit 5. For now, no need to remember. And most of the D block elements form colored compounds or colored complexes, we say. So in a laboratory, if you see a colored solution, that is mainly because it might contain a D block element. For example, potassium permanganate, we call it as sometimes condis. Potassium permanganate KMnO4, right? So purple color KMnO4, it gets that purple color. You have manganese there, which is a D block element. Then we have orange color potassium dichromate K2Cr2O7. We have chromium there, that's why it is orange color. It contains a transition element, right? Copper sulfate, we all know that, that is blue color. We have copper, that's why it has that blue color. The reason why they are getting colors we are going to talk about in A level in A2, but just remember transition elements or the D block elements, if they are getting a color, right? So that is for the D block, and the final one is F block. So the last two rows, right, of the periodic table, we call them as F block, the last two rows. And in the F block we have two types, we call them as lanthanide series and actinide series. And lanthanides and actinides are, we are not going to talk about them. They are electronic configuration fields to the F subshell. That's why we call them as F block, right? And all the F block elements are metals, and some of the F block elements are radioactive and some of them are very rare to find. Generally in the periodic table we have English names, but there are some elements that are actually have Latin names. So the Latin symbols are there, the name wise, but we use the English name. For example, sodium, right? Symbol is Na because in Latin we call them as natrium, right? Latin we call them as natrium. That's why it is Na without being SO something for sodium, right? Likewise we have potassium. I'll write few, it is K because in English, Latin it is kalium. That's why it becomes K. Likewise we have tin, for example Sn because it is stannum. Likewise iron, Fe, ferrum, tungsten, W, wolfram, mercury, Hg, hydrochlorium, silver, Ag, argentum, antimony, Sb, strontium, like that. We have different names that we used to have for the some elements, but with the evolution and in the 19th century the most powerful nation was British, so because of that English was the main language and now we use the English terms, right? So that's a rough and basic idea about the periodic table that you have to know in AS level, and depending on the elements present in the periodic table, we use their properties and we talk about that under a topic called periodicity. So in the next video, we'll talk about periodicity and what it is. So if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.